Hello all. Now we are going to see how to apply the Floyd Warshall algorithm. Floyd Warshall algorithm is used to find the shortest distance between any pair of vertices. See how is it different than the Dijkstra's algorithm. Dijkstra's algorithm is giving us the shortest distance of the source node from any other node from the given graph, whereas Floyd Warshall algorithm is capable to give the shortest distance between any pair of the vertices. So before we apply the Floyd Warshall algorithm, we'll make it clear about the intermediate node. So say there is a direct path between these two vertices. If edge exists between two vertices, that does mean that V is directly reachable from U. In another case, V may be reachable from U via any intermediate node K. So when the V is directly reachable from the adjacency matrix itself, we can have the distance between the pair of vertices. Consider this edge AB, where B is reachable from A, which is at distance 5 from the A. So from the adjacency matrix, this distance is mentioned. Another one is the C is reachable from B and it is at distance 3 from B. So that distance is also mentioned with the adjacency matrix. So wherever a direct path are available, that gets reflected in the adjacency matrix. So Floyd Warshall algorithm is considering the intermediate node between this U and V. So V is reachable from U via K. So in that case, distance UV could be calculated based on distance UK and KV. So this distance UV is equal to distance UK plus distance KV. So this is the basic concept used in the Floyd Warshall algorithm. As we have 4 nodes with the given graph, each and every node is going to be considered as the intermediate node, and accordingly we are going to find out the distance between U and V. So as we have 4 nodes, 4 iterations are going to be carried out. So in first step or in first iteration, we have considered A as an intermediate node. So when we are choosing A as an intermediate node, we have 3 choices to choose as source node. So B, C or D could be chosen as the source node, and whatever source node has been chosen, the remaining node from the remaining nodes, the destination nodes could be chosen. So here A has been selected as a source intermediate node, and B has been selected as a source node. So remaining nodes are C and D, which could be treated as destination nodes. So this is the U, this is the V, this is also considered as V. So distance BC is equal to distance BA plus distance AC. Distance UV is equal to distance UK plus KV, where K is acting as an intermediate node. So that formula we already studied. UV, this distance could be calculated as distance UK plus distance KV, where K is an intermediate node. So the same formula has been applied here. Distance BD is equal to distance BA plus AD. But as distance BA is unknown, here infinity representing the unknown distance. As this distance BA is unknown, we are not able to calculate the distance BC. Okay, so it becomes infinity itself. Even though we know this distance AD, which is 10, as BA is unknown, we cannot calculate the distance BD. Okay, it is also unknown to us. Now second case, C is source node. Still A is acting as an intermediate node as that of the previous case. Now instead of B, we are treating this C node as a source node. So remaining nodes are B and D. As we have only 4 nodes, A, B, C, D, A is selected as the intermediate node, C as the source node. Remaining nodes B and D are treated as destination nodes. So this is the U node, this is the K node, and this is the V node. So distance UV, that is distance CB, is equal to distance CA plus AB. Distance CD is equal to CA plus distance AD. Now as CA is infinity, we are not required to calculate the total distance because it is going to be infinity itself. Now third case is that where D is selected as a source node. So still A is an intermediate node, D has been selected as a source node. So remaining nodes B and C are treated as destination node. Distance DB is equal to distance DA plus AB. As DA is infinity, again no need to perform calculation, it is infinity itself. Distance DC is equal to distance DA plus AC, which is also infinity. So what we have found with the first iteration, that there is no any updation in the distances. It is same as that of the original adjacency matrix. So that's what mentioned here. This is the output of the first iteration, which is same as that of the original adjacency matrix. Now coming to the second iteration, where we are going to treat this B as an intermediate node. As B is acting as an intermediate node, any node from the remaining could be selected as the source node. So with the first case, A has been selected as the source node. With second case, C has been selected as the source node, and with the third case, D has been selected as the source node. And based on these choices which are made for intermediate node and source node, the remaining nodes are treated as destination nodes. So with the first case, A is source node, B is intermediate node. By applying the formula distance UV is equal to distance UK plus distance KV, distance AC becomes distance AB plus distance BC, which is equal to 5 plus 3, 8. With the previous iteration, this AC is infinity. As infinity is greater than 8, this infinity will be replaced by 8. Next, distance AD could be calculated from distance AB plus BD. Since BD is infinity, the total distance will be unknown. Here it is not representing a higher value or larger value. Instead, it is representing that this distance is unknown. It is to be calculated. It is to be determined. In second case, we have treated this C as the source node. So accordingly, we have selected A and D as destination nodes. So distance CA becomes distance CB plus distance BA. As both are infinity, the total distance is infinity. Distance CD is equal to CB plus BD, so which is also infinity. Next, D is considered as a source node with the third case, and with which this DA and DC, these distances have been calculated, which is infinity itself. So the output of the second iteration it's shown here, where we find a updation with this AC distance only. Now moving with this third iteration. With first two iterations, we have treated A and B as intermediate nodes. Now third choice is where C is selected as an intermediate node. So we have again three choices. With first case, A is treated as the source node. With second case, B is treated as the source node, and with the third, D is selected as the source node. And from this, based on this source node and this intermediate node, the destination nodes have been selected, and accordingly the distances UV are calculated. So distance AB is equal to distance AC plus CB, distance AD, this distance, it is equal to distance AC plus CD. Then see here, distance AD is equal to distance AC plus CD, which is 8 plus 1, 9. With the previous iteration, it was holding, AD was holding 10 distance, which is greater than the newly calculated value. So we will replace this 10 by 9. So that is the first updation we need to make. Next, when B is treated as a source node, we are able to calculate BA from distance BC plus CA. Since CA is infinity, total distance becomes infinity itself. That means it is unknown to us. Distance BD could be calculated as BC plus distance CD, which is 4. Now with previous iteration, it was holding infinity. So this infinity will be replaced by 4. With the third case, D has been treated as a source node, and with that it enables us to calculate distance DA and distance DB, so which is infinity. So this how we may come across the output of the third iteration, where we have updated two distances AD and BD. Now coming to the fourth iteration, we are here we are left with only one choice, that is D. D is to be treated as an intermediate node. Again, it arises three cases. Case 1, where A is treated as a source node. With case 2, B is considered as the source node. With case 3, C is considered as the source node. And based on the choices of source node and intermediate node, the remaining nodes are treated as the destination nodes. So distance AB has been calculated from distance AD plus distance DB. Distance AC has been calculated from distance AD and distance DC, which is infinity itself. So no any change occurs with the previous held distances. Then B is considered as a source node, and this how we are able to calculate BA and BC distances. Here also we find no any change. It results into the infinity value, means distance is unknown to us. Then on treating this C as a source node, we are able to calculate distance CA from CD plus DA and CB from CD plus DB. So that also results into the infinity value. So this is how whatever result we obtained in the third iteration, that remains same on performing the fourth iteration too. So this is the final result. So here if you consider any pair, if you consider the BC, then this is the shortest distance. See, this is the given graph. If you consider BC, Then BC, this is able to give us the shortest distance 3. If you consider BD, then this is the shortest distance, B to C, C to D, that is 3 plus 1, 4. If you consider AC, then B is reachable from A and C is reachable from B. 5 plus 3 is 8. AC distance is 8. Any pair you may choose and you may confirm this result. If you consider D, AD direct path is available as edge exists between these two vertices, but it is of 10 distance, whereas if we go through these nodes, A to B is 5, B to C is 3 and C to D is 1, it results into the 9 distance. So see here AD is 9. So Floyd Warshall algorithm is able to give us the shortest distance between any pair of vertices. So any two vertices you may choose and you may check whether it is resulting into the shortest distance or not. Thank you.